Okay, so today we're going to be talking about potential dividers. Now, this is a topic that quite often students find it difficult to understand, but actually, again, it's really quite simple. What we need to do is we need to remember some basic rules for how voltage and resistance operate in both series and in parallel. So if we start off with in series, so if we draw a very basic circuit, so we'll give ourselves a battery, and within the circuit we'll place two resistors, and we will then call these R1 and R2. And if we measured the voltages across these, we could call them V1 and V2. So the voltage input, so the electromotive force that's being given out, is measured across here. And so V in is going to be equal to V total. So that is going to be the total energy that is being supplied to this circuit. Now, because the energy is being supplied, because electrons or whatever charge carriers are going on are being sent through here through a potential difference, they've got to transfer all that energy by the time they reach the terminal. So that means that they're going to expend all their energy within the components in the circuit. So we could say that V total is equal to V1 plus V2. And if we had any other components in this circuit, then we'd just add them on, okay? Because it would just continue to be shared between the components within the circuit. So this is for in series. Now we need to think about in parallel. So again, if we just draw ourselves a battery and then we put two resistors in parallel, and we look at what the voltage is going to be across here. Now, because they're going down different branches, there are different charge carriers going down each branch. Each of them has been given energy by the cell, the power supply. So if they're going down only one branch, each of them, they're only going to pass through one component on their route back to the power supply. So that means they're going to transfer all of their energy back to each one. So the voltage drop across each branch is going to be the same. So for this case where we have just two components in parallel, V total is going to be equal to V1, which is going to be equal to V2. The more generalized version of this is to say that components that are in parallel will have the same voltage across them. Another thing we need to know about is how resistance adds up in series. So resistors in series, the resistance is going to increase the more you add in, because a resistor is just anything that is preventing or trying to slow down the flow of charge. So the total resistance in this circuit, or R total, is going to be equal to the sum of the resistors. So in this case, R total is equal to R1 plus R2. But how is this voltage going to be shared between them? Well, if we think about it, if you have a greater resistance, you're going to have to expend more energy to overcome that resistance. So the higher the resistance, the higher voltage is going to be across that component. So if you have an increased resistance, it's going to get an increased share of the voltage. So let's have a look at the relationship between the resistance and the voltage. We can do this by using Ohm's law. So if V is equal to I times R, we can say that V1 is equal to I times R1 and V2 is equal to I times R2. Now, because this is a series circuit, the current is going to be the same throughout the entire circuit, so I remains constant. This leads us to being able to rearrange these equations to say this, that V1 over R1 is equal to V2 over R2. We could rearrange this again to put them into ratio. So we could say that V1 over V2 is equal to R1 over R2. So the ratios of the voltages and the resistances is going to be the same. Because we know that R increases, when R increases, it increases its share of the voltage, we could state something like this. We could say that V2 divided by V total is going to be equal to the same thing as R2 over R total, because they're going to be in ratio with each other. They're going to have the same proportion. We could rearrange this one more time to say that V2 is equal to V total multiplied by R2 over R total. So you can use this equation to find out what the voltage across a single component is going to be if you know the total voltage, the resistance of that component, and the total resistance within the circuit. So in summary, you can find the voltage or the energy transferred to a component by knowing the total energy that's being transferred in the circuit and multiplying it by the ratio of the component resistance and the total resistance. Now, sometimes this gets written out in a different way. It gets written out like this. V out is equal to V in times by R2, R1 plus R2. Now, the reason for this is it's relating to a particular circuit. And that circuit looks a bit like this. So if you have a potential difference between these 2 points, so it's as if you've got a battery in between, okay, but we don't show this bit. Okay, so this is just saying there is a potential difference between these 2 points. And then we've got one resistor here, and then we have a parallel circuit coming off of here. So this is our potential divider. We're dividing the voltage between these 2 resistors. So that's R1, R2. So between here and there, that is V in. So that is the potential difference between these 2 lines. And then over here, we have V out. Because quite often these circuits are used to vary the voltage in a completely different circuit. So you could build another circuit using this then as your power supply. This is your source of voltage. So in essence, potential dividers are just a mathematical way of describing how the voltage is split up within a circuit.